Okay, so today we are working on radical expressions and rational exponents. So we're going to rewrite radical expressions. We're going to have different radicals besides just the square root. And we're going to use rational exponents. Okay, so we know what an exponent is. We also know and have said before that rational, another name for rational, is just a what?
Fraction.
It's just a fraction. Okay, so we're going to pay special attention to some of the directions. And then we're going to do a lot of simplifying and evaluating with radical expressions and expressions containing rational exponents. Okay, so exponents that are fractions. So what I asked you to do is simplify the square root of 40 and the cube root of 40. So when we approach this, Alyssa, what's the first thing that we're looking for number one? Okay, and why would you want to split it into the square root of 4 times the square root of 10?
Because then you can take the square root of 4, which is 2, and then 2 times 4 times 10.
Good. So the reason why we chose 4 times 10 instead of, say, 8 times 5 is 4 is what we call a perfect square, so we can take the square root of that and then it simplifies. Do we remember why the square root of 4 is 2? Mm-hmm.
2 times 2 is 4.
Okay, so it has to do with the number of factors, right? The square root of 9 is 3 because it's 3 to the second power. So if you have a square root, the square root undoes what? Can be with me. Yeah, it undoes an exponent. Okay, so roots and exponents, those are inverse operations. So now, when I move over to the cube root of 40, okay, I can't simplify this the same way. I need a perfect cube. What's a perfect cube that goes into 40?
8.
Okay, so then this one you'd rewrite as the cube root of 8 times the cube root of 5. The cube root of 8 we know is 2, so this would be 2 cube root of 5. Don't forget to make sure you specify that it is the cube root. Okay, so we're going to be working with different radicals. So to help familiarize ourselves with some of these different perfect roots, we're going to generate a few lists. Okay, and I am going to let you use your calculator to help you with this, but with some of this we don't have to. So for the perfect cubes, 1 to the third power is 1, so 1 is a perfect cube. And I want you to write this out just like I am, please. 2 to the third power is 8. 8 is going to be a perfect cube. And what this means is if you take the cube root of 1, you're going to get 1. If you take the cube root of 8, you're going to get 8. Now, something with cubes that's special is the positive and negatives. We're also going to talk about that. So the cube root of 27 is, I put 8. What should have this been? What's the cube root of 8? 2. The cube root of 27 is 3. Okay, and then it says list the first 5. So we're going to do 4 cubed. So 4 times 4 is 16. What's 16 times 4? 64. So then we're going to do the cube root of 64, which is going to be 4. And then 5 cubed, that's something you should know right away. Yep. And then you have the cube root of 125, which is going to be 5. And then I'm just going to have you box in these values. Those are going to be your perfect cubes. Okay, and then we're going to do the same thing with the fourth roots. Okay, so we're going to start it the same way. 1 to the 4th is 1. 2 to the 4th. So when you're doing this you can do without a calculator too. What's 2 times 2? 4. 4 times 4 is 16. Okay, 3 to the 4th, just think of what's 3 squared. What? 3 squared isn't 81.
No, it's
I know, but what's 3 times 3? 9. So really, don't you have just 9 times 9? So that you can do without your calculator. When you're doing 4 to the 4th, Just think of 4 squared times 4 squared. 16 times 16 will be 256. 5 to the 4th is like 25 times 25, which will be 625. Okay? So these are going to be your perfect fourth roots. So the fourth root of 1 is 1. Fourth root of 16 is 2. Fourth root of 81 is 3. Fourth root of 256 is 4. Fourth root of 625 is 5. Okay, and then we're going to do the same thing with the 5th and the 6th. Okay, so I'm going to give you a minute to finish those. And then if you finish those, I want you to go on and read this. And then think about these two questions here. Okay, so like I said earlier, you are going to have some of these that you can do with a calculator. Other ones you won't be able to use a calculator, so we're going to talk about some of those strategies that you can use when you have to do a radical without a calculator. Do you guys know how to do different roots on your calculator? Like if you wanted to do the 5th root of 3,125, would you know how to do that? So if you want to do the 5th root, you press 5, you go to math, and then there's a x root here. That's why you have to put the 5 in first. Okay, and then it will tell you what your root is. Okay, so you can try that with any one of these. Okay, so now we have our list of perfect cubes, 4th roots, 5th roots, and 6th roots. Now we're going to talk about some terminology. This is, what is the index of a radical? Okay, so the index of a radical is going to be the number that sits right here. So if it's of your form, the nth root of a is usually what they'll say in general. You have the nth root of a, the value of n is the index or root. Okay, so we either call that the index number or the root number. All right, what does it mean if there's no index? So by that, it's if you can't see it. So if you couldn't see it, it would look something like you just have this. What does that mean? That's the square root. Okay, so if you can't see the index, then it's going to be the square root. The reason why we want to make a point to say that is I never want to see this. This is not proper form. You are not going to put the 2 there. Okay, it's an understood value that if you have a square root, you will not see the number 2. Okay, so you do have to write the square root like you have been. Okay, so in this case, your n value would be 2. All right, now we're going to talk about the number and types of real roots. So the first one is talking about if you have an odd index. Okay, and the example is the cube root of 8. If you take the cube root of 8, the only possible answer is 2. There is only one real root. The reason why is if you took the cube root of -8, what would you get? No. So if you are thinking in terms of your cube root, think about why the cube root of 8 is 2. That's because if you do 2 times 2 times 2, what are you going to get? 8, right? 4 times 2, positive 8. If you had -2 multiplied 3 times, -2 times -2 is 4. 4 times -2 is -8. So if you do the cube root of -8, what would you get? -2. Okay, so there would only be one possible answer. Okay, so if it's odd, it's going to have the same sign as the radicand. So it says even index positive radicand. What do we think the radicand is? Yeah, yep, it's your number underneath your radical. Okay, so I will use the term radicand, and we do need to know what that means. So if it's an even index and you have a positive radicand, so a positive number underneath the radical, there are going to be 2 real roots. The example is the 4th root of 16. So if you were doing the 4th root of 16, it would be plus or minus 2, because if you multiply 2 4 times, this would be 4 times 4, which is going to be 16. Or if you multiply -2 4 times, what happens when you multiply a negative by a negative? Yep, it becomes positive. So it's still 4 times 4, which is 16. This all has to do with odd and even roots and having your positive and negative multiplication rules. So if you're multiplying an even amount of negatives, you'll always get a positive. If you're multiplying an odd amount of negatives, you'll always get what? A negative. Okay? And that's just based on something you know. A positive times a positive is a positive. A negative times a negative is also a positive. Okay, if you have an even index, but what's underneath the radical is negative, there are no real roots. Okay, notice it says no real roots. Whenever you have negatives underneath the radical, what kind of roots does it produce? Imaginary. Okay, and the last one is your radicand of 0. So it doesn't matter what the index is. If it's 0, you're always going to get 0 as your root. Okay, the cube root of 0 is 0. The fourth root of 0 is 0. The square root of 0 is 0. Because 0 times 0, no matter how many times, is going to be 0. So that's going to help us with our first example. It says find all real roots. Okay, so they do have to be real. All right, so if they're asking you for the 6 roots of 64, okay, what this means is we're doing the 6th root of 64, which I know we just did that on our chart. So you do have that value there, but you can also think about how you can break this down into a factorization. So if you have a square root and you need 2 factors in order to get out of the square root, how many factors do you need to get out of the 6th root? You need 6. Do you guys remember how to do prime factorizations? Okay, so it's just you're going to break 64 down into prime numbers. So when we think 64, probably one of the first things you guys think of is what times what? 8 times 8. So 8 times 8, and then 8 is 2 times 4. 4 is 2 times 2. So really, isn't 8 just 2 to the 3rd power? Okay, so this 8 I'm just going to break down right away is 2 times 2 times 2. The prime factorization is 2 times 2 times 2 times 2 times 2 times 2 times 2, which is too many 2's. 1, 2, 3, 4, 5, 6. Okay, so if you have the 6th root of 2 to the 6, what happens? Yeah, the 6th power cancels out with the root, and you're left with 2. Now remember, because it is an even index, a positive radicand, you have 2 real roots, so you're going to put your plus or minus. Okay, for the cube roots of negative 216. If it's an odd index, you're going to keep the sign of the radicand. Okay, so if it's a cube root, this is odd. This is negative. Okay, so your answer should be negative. Okay, you didn't get to 216 on your chart, so you just have to go 5 cubed was 125. So the next thing I would try is you can do the cube root of negative 216, or you can just do, 6 cubed is 216, so I know this has to be negative 6. Okay, so odd roots, keep the sign of the radicand, whatever it may be. If it's positive underneath, it'll be positive. If it's negative underneath, it'll be negative. Okay, so for this one, we had it even, and this was positive, so we use that rule. For this one, the 4th root is even, and then this is negative. Now, if it's even and negative, okay, what are we always going to say? If it's even and negative, then there are no real roots. Now, this isn't even a perfect root anyway, but there's going to be no real roots because you can't take an even root of a negative. All right, so now we're going to talk about some more properties of roots. Okay, so these are properties of radicals or properties of nth roots. Usually you guys have these little rules, these little stipulations that are easy to glaze over. So we're going to make sure we understand what conditions this satisfies. So if it's saying A is greater than 0 and B is greater than 0, what does that mean just in words? Has to be? Has to be positive. That's all that it's telling you. Okay, so in this case, your A and your B are going to be positive values. Okay, so if A and B are positive values, what we can do is use the product property and the quotient property. So the product property is something that we used on our bell work today, and it's something you've been using for a long time. It's just sometimes we forget about these things that we know, or when we put them all together, we get unsure of when we can break things apart and when we can't. So this is our rule, okay? If you have a product, then you can rewrite, okay, the product A times B as the nth root of A times the nth root of B. Okay, for this one, they call this the quotient property, but it's easy to think of it like a fraction. Okay, when you're doing that, you're doing the square, or whatever root you have, you're going to rewrite as a root in the numerator and another in the denominator. You guys should be annotating this with me, okay? If you hear it once, sometimes we're zoning out in our own world, so that's why it helps for you to write it down so you can concentrate on what we're trying to visualize here. So if we're looking at 25 over 16, sometimes people will just try to take the square root of that right away in their calculator, and then you get some kind of decimal. That's not what we should be doing. We're going to think about our perfect squares. So if you do the square root of the top, you get 5. Square root of the bottom, you get 4. Okay? If you have a cube root, you're thinking of, oh, what's a perfect cube that goes into 16? Now this one's simplified. It's not always going to simplify when you have a fraction. So if you had something like this, 2 over the square root of 5, right? What do you need to do if the denominator contains a radical? Yep, and that's called rationalizing. Okay, so what do you need to do if it contains a radical? You need to rationalize the denominator. All right, now a lot of you know how to do this. You're multiplying the top and the bottom by the square root of 5. The reason why you're doing that is because when you multiply the square root of 5 times the square root of 5, you get the square root of 25, which just simplifies to what? 5. Remember, as we go through this, that the reason why that happens is because this is the square root of 5 squared, and so the square root and the power of 2 undo one another. Okay, so we're going to think about that to help us with some of our next problems. All right, let's flip it to the next page. So we are simplifying each expression. Okay, so simplify is a common word that we'll see that we have to do. And it really covers a multitude of different operations. Okay, when you say simplify, what you should be thinking about is, okay, if I have a root, you need to find the perfect roots and bring them out. Okay, another thing that we have to do is rationalize. If there's a radical in the denominator. And then the last thing is we have to reduce any fractions. Okay, like we did earlier in chapter 5. Notice here it also says assume that all variables are positive. That just means that you do not have to worry about writing your plus or minus. Okay, so you're not going to have that in your solution. Okay, so we are going to simplify. So we have the fourth root of 81 x to the 12th. And you guys might remember doing some of these in Algebra 1. So you can see these have a mixture of numbers and variables. Okay, so what we're going to think about is the number and then the variable separately. Okay, so we have the fourth root of 81. Right, this can cancel out if we can rewrite 81 to the fourth power. So if we're doing this without a calculator, which this would be one that you could do without a calculator, let's break it up into what we know. So 81 would be what times what? 9 times 9. And then 9 breaks into 3 and 3, 3 and 3. Really, what I'm doing here when I'm doing this, I'm thinking of this as the fourth root of 9 times the fourth root of 9, which, according to the product rule, I can do that. And then I'm breaking up each one of these. So it's like I have the fourth root of 3 times the fourth root of 3 times the fourth root of 3 times the fourth root of 3. Now if you multiply all of those together, right, this becomes 3 to what power? If you have 1, 2, 3, 4s, it becomes 3 to the fourth power. Why is that helpful? Yep, those are going to cancel and you'll be left with 3. Okay, so when you're doing this without a calculator, you want to think of your prime factorization. Okay, this breaks into 3 times 3 times 3 times 3, and we know that the fourth power of 3 to the fourth is going to be 3, so that's going to be part of our final answer. Now we have to simplify the fourth root of x to the 12th. So really, you're doing a similar process where you want to break this into groups. So if I have x to the 12th, because it's the fourth root, I want to break it into groups of 4. So I'm just going to write it like this first. X to the 4th times x to the 4th. How many x's do I have here? It's either 8 or 16, right? What's the rule? When you're multiplying, what do you do to the exponents? Add. So I have 8. So if I do times x to the 4th, how many do I have altogether? 12. So I have 3 groups of 4, right? So if I rewrote it like that, remember, this is all under the fourth root. So it's like I have the fourth root of x to the 4th times the fourth root of x to the 4th times the fourth root of x to the 4th, which when these simplify, I'm going to get x times x times x, which is what? This is going to be x cubed. When I think of this, this is the fourth root of x cubed to the 4th, because if you have a power to a power, what's the rule? You multiply. So then those two undo each other, and you have x cubed, and that goes to part of your final answer. So your final answer is going to be 3x cubed. Now, whenever you're doing this, I'm just going to write exactly what I say to myself. How many times does 4 go into 12? And obviously the answer to that is how many times does 4 go into 12? 3. And that's why I have x cubed. You do have to think of these differently, because I'm not asking myself how many times does 4 go into 81. Is 81 divided by 4 3? No, because 4 times 3 is 12, right? Okay, so these are different, the variables and the numbers. So how many times does 4 go into 12? Because 4 is your index, okay, and then 12 is your exponent. So when you're doing the thinking, you can always do it in those terms. Okay, if you haven't already started part B, go ahead and do that. Okay, so for this one, the first thing we're going to look at is the 4th root of 16. And really, eventually, if it isn't already, you'll get to memorizing that. So 16 we know is 4 times 4, and each 4 breaks into 2 times 2. Okay, so the prime factorization, what does the prime stand for? Yes, yeah. So the prime part of the factorization is all of these are prime numbers. And 2 times 2 times 2 times 2 is going to be 16. So the 4th root of 2 to the 4th is going to be 2. And then you can say to yourself, okay, how many times does 4 go into x to the 4th? Or sorry, how many times does 4 go into 4? 1 time. So then your final answer should be 2x. Okay, how do we do? Do you remember some of that from Algebra 1? Okay. So now we are going to move on to when it doesn't go in there evenly. So you're going to think of this the same way, right? How many times does 3 go into 7? 2. Do you guys know how many would be left over? 1. So then do you think you can write the final answer? Okay, so if you were to rewrite this, it's x cubed times what? X. No, just x, because you have, how many x's do you have here? 3 plus 3 is going to be? 3 plus 3 is going to be? 6. And then this extra one is going to be 7 altogether. Okay, so when you're splitting these up, the cube root of x cubed times the cube root of x cubed, those cancel. That's where you get the x times x. But the cube root of x, you can't simplify that. So you're going to have to leave it as x squared times the cube root of x. This would be your final answer. Don't forget to put your index here. The way that you're writing these out is important. I know some of you get a little messy sometimes. You need to focus on how you're writing your exponents, how you're writing your index. Cam, put that away unless you want it to be mine. I don't want to have to tell you more than one time. Once you have this, I want you to think about how it's only going to come outside if it has a group of 3. So that means inside the radical, your exponent should never be bigger than what? Yeah, for this one, 2. Yep. What would be the rule? The exponent. Yep. So the exponent inside the radical should never be greater than your index. Because if it was, then you could take another group out. Okay, for part D, we have the 4th root of, and this is going to be a fraction, 16x to the 8th over 5. And then E is going to be the 4th root of x to the 9th over 3. You might feel like, oh, that escalated quickly. Okay, so with the division, with your quotient rules, remember that you can split this up into the fourth root of the numerator over the fourth root of the denominator. So this is like the fourth root of 16x to the 8th over the fourth root of 5. So we can simplify now if possible. The fourth root of 16, what's that going to be? 2. How many times does 4 go into 8? 2. So I'm going to have 2x squared on the top. I can't simplify the fourth root of 5, so I'm going to have to do what? I'm going to have to rationalize. Now, when I'm doing that, the most common mistake is going to be to rationalizing how you've always done it. So you can't just multiply. You don't have to write this part down. I'm going to show you why this is wrong. Okay, so remember, before when we had the square root, we had 2 over root 5, which we multiply by root 5 over 5, and we got 5 on the bottom, right? Remember, that came from, this is the square root of 25, and the square root of 25 is 5. So if I just multiplied the top and the bottom by the fourth root of 5, remember, this is the fourth root of 25. Is the fourth root of 25 5? No, the square root of 25 is 5. How many 5s am I going to have in order to take it out so I have a whole number?
3.
I'm going to need 3 more. I need 4 total, right? Okay, so I need 4 5s. I already have 1. So when you're thinking about what to multiply by, I'm perfectly fine if you write it as you're multiplying by 5 to the 3rd power. Because if you're multiplying by 5 to the 3rd power, in the denominator, which is the whole reason why we're doing this, you'd have the fourth root of 5 to the 4th, which of course would simplify to 5, because those would cancel. Now on the top, you are going to have to simplify this part here, right? What is 5 to the 3rd? 125. We know that that's not going to simplify because you only have those 3 factors, and 5 is a prime number. So this is our final answer. Okay, it's going to be 2x squared, fourth root of 125 over 5. Again, make sure that you have that written out correctly. So it should be clear that it's 2x to the power of 2, that 4 is the index in your root over 5. Okay, so based on that, do you guys feel like you can do E? Part E? So this one was a little bit different because the top didn't simplify completely, but that's okay. Okay, so then you ask yourself, how many times does 4 go into 9? How many times does 4 go into 9? 2 times. So x squared comes on the outside. how many do you have left if you take out, not 2, but you took out 2 what? 2 groups of 4. Okay, so then how many would you have left? 1. And then don't forget, this is the 4th root. So on the top you have x squared times the 4th root of x over 4 root 3. Okay, so then, Damien, what do you want to multiply by on the bottom to rationalize? Or if you're not sure, tell me and we'll figure it out together. Damien, what are you thinking? Or do you want? Yeah, did you do it?
Yeah.
Okay, what'd you get?
Or the 4th root of 3 to the 3rd.
Good. Yep, the 4th root of 3 to the 3rd. And then why did you decide that?
Because the bottom can't be
Yes, so once you multiply, that means on the bottom you'll have the 4th root of 3 to the 4th, which anytime you have the 4th root of the 4th power, that will cancel. And then on the top, we're just going to simplify. So we have x squared times the 4th root of x times 3 cubed is 27. Now notice, we have the 4th root of x times the 4th root of 27. Because those have the same root, you have to rewrite it as x squared 4th root of 27x. So those are both going to stay inside. So your final answer is x squared 4th root of 27x divided by 3. You cannot cancel these because if it's in the root and outside the root, you will not reduce. Okay? You can only reduce if they're both outside or if they're both inside. So that's a good thing to remember. Okay? You can only reduce if they're both outside the radical or if they're both inside the radical. All right, rational exponents. Remember, another name for rational is what? A fraction. Okay, so the rational exponents, it says this is true for any natural number n and integer m. Do you know why they said natural number here instead of integer? It can't be 0. Okay, but it can be negative. So in words, it says that the exponent 1 over n is going to indicate the nth root. Okay, so this is our rule. We're actually going to write it down below. So if you have 16 to the 1 over 4, it's the 4th root of 16. Okay, we can apply this to other situations. If you have a to the 1/2, okay, if 1/4 is the 4th root, 1/2 is the what? Square root. Okay, if you have a to the 1/3, that would be the cube root. Okay, now you're not always going to have a fraction where 1 is the numerator. So that's where the second one comes in. If you have the exponent of m over n, that's going to be the nth root, but you have to raise it to the nth power. Okay, so it's the nth root raised to the nth power. So here's our example. So based on this, if you have m over n, you have the nth root to the power of m, which means, okay, the denominator of the rational exponent becomes the index, okay, or root of the radical. All right, so we're going to just reinforce those things we just talked about. So the first thing we have to know is anytime you have 1 over n that's going to be the nth root of your a value. It really is the same thing as this. It's just if you raise anything to the first power, you're going to get the same thing. Notice here that you have two equations. Okay? There is going to be one that's easier to do in your head, and so we're going to practice figuring that out. So if you have a to the m over n, remember, it's the denominator that becomes the index or the root. So this is going to be the nth root of a, and then you have a choice. So you can raise it all to the nth power like this, or you can do the nth root of a and raise a to the nth power inside the radical. Okay, so you still have your index, it's just the power can be done after you do the root, or it can be done before. Okay, so the power is done before you take the root, or the power is done after you take the root. When you're doing these, an easy way to remember which one is which, we're going to draw a visual representation of this. I'll tell you what I think of. So the bottom number is the root, right? So when you think of roots, where do roots grow? In the ground, right? The roots of a tree or a plant grow in the ground. Okay? Are you guys laughing at my roots? Those are really good. And then on top, if you're on top, then you got the power. So we got a little crown here. Fancy with these little guys on there. Okay, so when you're on top, you got the power. Roots grow in the ground. And that's how I remember which one is which. All right, so for example 3, we're going to write each expression in radical form. So if you're going to write it in radical form, your first step has to have a radical in it, and then you're going to simplify. So for a, we have negative 32 to the power of 3/5. B, we have 64 to the power of 1/3. C is 4 to the 5/2. And D is 625 to the negative 3/4. Okay, I'll tell you right now, these are ones that you'll have to know how to do without a calculator. I'll show you why in a second. Okay, so the negative 32, the 3/5, we know that the denominator is going to be the root, so I have the 5th root of negative 32. Now I get to decide where I want to put the power. If I don't have a calculator, am I really going to want to do negative 32 to the 3rd power? No. Okay, so let's put it on the outside. But do I know the 5th root of 32? Really, we should.
Yeah.
It's 2. Okay, so the 5th root of negative 32 is going to be what? Negative 2. So then when you simplify this, it's negative 2 to the 3rd power. And what's negative 2 to the 3rd power? Negative 8. See how simple that is? Why don't I want you to use your calculator on this?
Because we can't use a calculator in the real world.
No, because look, you don't even have to know the properties. You can just plug it into your calculator and it's doing all the thinking for you. Okay? Also,
Isn't that what the point of the calculator
no.
is for us?
When you go to pre-calculus, you're going to have to do all this without it.
What's the point of a calculator?
The point of a calculator is to do high calculations quickly.
Calc isn't the name of pre-calc.
But
I know, but you have to have strong mental math skills. And we've already talked about how you're getting ready for your SAT and your PSAT, and you're not going to be able to use a calculator on there. Okay? The calculator is not in place of you thinking. And you guys are all smart enough to understand these basics. So your cube root of 64, when you're doing the cube root of 64 without a calculator, remember you can break this into more manageable pieces. So you can do the prime factorization. So when you do the prime factorization, like you're thinking, oh, it's 8 times 8. Well, we know 8 is what? 2 times 2 times 2? 2 times 2 times 2. So you could think of it as the cube root of 2/3 times the cube root of 2/3. Or really, don't we know that 8 is a perfect cube? So can I just think of this as the cube root of 8 times the cube root of 8? What's the cube root of 8? I know. So the cube root of 8 is just 2, right? 2 times 2 is 4. Now some of you might even know right away the cube root of 64 is 4. You did what?
We did a whole lesson on all those. On all the cubic roots.
Yeah, yep, your perfect cubes. Yep, you wrote them down on the front. So some of you are going to recognize that right away, and you'll be able to just go to 4. I'm just showing you a different way. If you get to one where you're like, oh, I don't remember if that's a perfect one or not, split it up into something that you do know. Okay, and then for this one, if you have 2, again, don't put the 2 there. It's the square root. So your power can go on the outside so that you can do this calculation quickly. What's the square root of 4? 2. 2 to the 5th is 32. All right, now for D, you're going to have to remember some things from the past because I have a negative exponent. Whenever you have a negative exponent, what should you do first? You're going to rewrite it as a positive. How do you do that? Yep, the reciprocal. So it's 1 over 625 to the power of 3/4. Because it's negative, right? So to make it positive, you're going to put the 1 over it. So now I can do the 4th root of 625 to the 3rd power. Okay, 625 is one of your perfect 4th roots that I know that you wrote down earlier, but another way to think of it is 625 is 25 times 25, and this would be 5 times 5, 5 times 5, so it would be 5 to the 4th power, and of course, if you have the 4th power, it cancels out with the 4. And what's 5 to the 3rd power? 125. Okay, so then you should have 1 over 125. All right, and then example 4 says write each expression using, oh, this should say rational. Okay, when you're writing this using, we'll do that one tomorrow. Okay, so your homework is online. Again, just do the ones that we've done here, and then the rest of them we will finish tomorrow.